Their Information Technology Systems Managers and Staff webinar series, brought to you on behalf of the Health and Human Services Administration for Children and Family, Children's Bureau, and presented by ICF International. Today's webinar is entitled CCWIS and Modular Design. I'm Elizabeth Martinko, and I'll be your host and your moderator for today's webinar. Attendees are encouraged to participate in our webinar with questions and comments. All of your lines are muted now, but we will open them for Q&A at the end of the presentation. However, please be aware that you can submit questions at any time using the GoToWebinar chat feature, and those will be addressed during the Q&A session. If you look, you should have a small orange arrow that appears, usually on the right-hand side of your screen, and if you open that up, you'll see a dialog box and a place that you can ask questions or put things in chat. Should we run out of time, we will respond to your questions via email, and if you have additional questions, you can submit those to me at the email address listed on the slide. Also, if you have any topics that you'd like to recommend as potential webinars in the future, please contact me and let me know. The Division of State Systems within the Children's Bureau continues to provide a series of monthly webinars supporting information sharing and discussion. Understanding who is attending the webinars helps us to identify content that is applicable for everyone participating in an agency's CCWIS efforts. So I'm going to go ahead and open up a poll, and if you could just please quickly self-identify which of the following groups you're a member of, so that we can get an idea of who our audience is. If you're participating in a group that's together in a room, just select the category that best represents the largest number of people in your group. And I'll just give people a few minutes to answer. Just slightly over half of you have responded, so if the rest of you can just go ahead and tell us who you are. We could just get about the last 10% of you all to identify who you are, of course, that'd be great. And it looks like we have 21% state child welfare information systems project managers. The biggest percentage is 66%, and that's state child welfare information system program policy or technical staff. And we also have a handful of ACF Children's Bureau personnel or contractors with us today. And at this time, I'm going to go ahead and turn things over to today's presenter, Dan Hon. Dan is a technology consultant to ACF.
Hi, good morning or good afternoon, everyone. My name is Dan Hon. As a former editorial director at Code for America, last year I worked to help the state of California transition from a large monolithic RFP to a modular, user-centered, and iterative procurement for a new CCWIS child welfare service. And as a technology consultant to the ACF, I am helping states learn and apply the principles of modular design, user-centered design, iterative and agile development, and modular procurement. So if we move on to the next slide, I'll talk about what today's presentation is going to cover. So we've got 6 main topics today. I'm going to go through the CCWIS requirement for modular design, then why modular design is being required, an explanation of what modular design is, an explanation and some discussion about how and why modular design is better than the historical alternative, how states and tribes might get ready for modular design, and how you might move from a monolithic design or a monolithic procurement to a modular design. And then after that, hopefully we'll have time for questions. So moving on to the CCWIS requirement for modular design. The requirement is laid out in section 1355, spot 53A, and roughly stated. It says that except as exempted in paragraph B, automated functions contained in a CCWIS must follow a modular design that includes the separation of business rules from core programming. And what we'll do today is that we'll talk a little bit about what that means and the implications for the design of CCWIS systems. On the next slide, you've basically got 2 types of exemption in 1355 spot 53B. So the first type of exemption is if you're in a transition period. So for the period where you're moving from an STACWIS system or a non-STACWIS system to a new CCWIS system, then that transition period is exempt. Or on a case-by-case basis, if your proposal is more efficient, economical, or effective, if you can show that your proposed design or your proposed implementation is going to be more efficient, more economical, or more effective than an industry standard modular design approach. So let's go into section 2. Why is modular design being required? So there are 3 main points to why I think ACF is making the move to modular design. And the first one is that modular design makes it a lot easier for automated child welfare information systems to meet user needs. And I think the reason why this is because when you have a modular system, you have much more, in principle, you have a lot more flexibility to make sure that each part of that overall automated system is able to precisely meet the needs of the users of that particular part. So, for example, it means that because you're not bundling everything together into one big recipe or one big monolith, you're able to say, well, these are the exact things that I need for, say, my caseworkers who manage intake, and these are the exact things that my users need for case management. If you are taking a modular design, that means that you're able to separate those parts of functionality out so that you're able, on one hand, to concentrate on, okay, well, these are the features, this is the functionality, this is what I exactly need for my users for intake, this is what I need for case management, this is what I need for resource management. So there is the potential with modular design that because you have separated out the different types of functions and you've grouped them together according to your different users and what your different users need, there's the potential for less need for compromise, for saying that, okay, well, if I need a system that does everything, then maybe I only get 60% of everything kind of spread across all of the different functionality. But with modular design, there is greater possibility that you'll be able to meet those requirements in each area. Moving on to the second point, modular design makes it easier for systems to be continuously improved rather than the usual model of procurement and then maintenance and operation. So whilst I don't have a long background in government technology, I think what I have seen over the past 9 months, and especially what I've seen in terms of child welfare systems, is that the traditional or historical model of government technology procurement over the past 20 years has tended towards that of treating technology a bit like plant and machinery. So we go out, we gather our requirements, and then we put them together into an RFP, and then we procure that system, and then in some cases that system then sits around for about 20 years, and we ensure the maintenance of that system and we ensure the operation of that system. But what that means is that we miss out on all of the benefits that accrue as technology improves. So, for example, the systems that were procured and built in the late 80s and early to mid-90s were most certainly state-of-the-art at the time, and some of them, even now, include very, very solid and dependable technology. But the model that we have used with those, where they are one big system that is treated as a whole, means that we can't, or it's more difficult for us to upgrade and continuously improve parts of those systems. So the intent with modular design is how do we move from this kind of big bang of procuring a system, every 10 to 15 years, and then having to more or less throw it out and then get a brand new one? How can we move to a system of continuous improvement to make sure that from a child welfare delivery point of view, we're able to take advantage of technology improvements as and when they happen? Because if there's one thing that we do know, it's that technology will keep changing. Technology hopefully will also keep improving. And we want to be able to take advantage of those benefits as they become available, rather than in a big bang every 10 to 15 years. And the third point about why I think ACF is requiring modular design is that ultimately it's going to help states and tribes deliver technology faster, more cheaply, and technology that's going to be more reliable. So to the faster point, I think what we're seeing is that it's incredibly important to be able to get technology that meets the needs of our users, of our caseworkers, of everyone involved in delivering child welfare, that takes advantage of the improvements and takes advantage of contemporary technology. We want to be able to get those systems out there, and I think it's very difficult right now when we enter, say, something like a 2 to 5 year procurement cycle, when by the time we've actually delivered on the procurement, then technology has moved along. We obviously always want to make sure that we're getting the best value for money. So we think that modular design is going to enable us to deliver better technology more cheaply. And the third part is that the intent is that modular design is going to help all of the technology that's used in automated child welfare systems become more reliable. So how do we deliver faster, cheaper, and more reliable software that's involved in the delivery of child welfare? So I'll move on to the third topic now. Just what is modular design anyway? So we'll cover kind of three topics here. The first one is an introduction to monoliths that some of you may or may not be familiar with. And then we'll compare modular design to monolithic design. And then we'll talk about how modular design might be applied to child welfare. So first, an introduction to monoliths. So traditional software development over the last few decades is normally known as monolithic software. We're on the next slide at the moment. And if we go to slide 14, the next slide. So roughly speaking, all of the software that gets developed, all the code that gets written, or all the code that comprises a system, more or less gets turned into one big artifact that is run on a server or a mainframe. And this means that conceptually, the developers and the vendors and the designers of the system think of the system as one big entity. And there's not really as much decomposition. There's not really as much splitting up as all of the functions. So one way of thinking about a monolith might be that, when you have all of the components of spaghetti bolognese together and you mix them all together, then it's very, very hard to deconstruct them. It's very, very hard to take them back into their constituents and then change them. So if we go to the next slide, sometimes that code might also get compiled into some client artifacts as well, like a Visual Basic application. And this is a model that I've seen in a number of states through my work with ACF. So traditionally, the type of legacy child welfare information systems that I've seen will have quite a lot of monolithic database and server code. And then there'll be a similar big client application that is treated as one single client application, like a Visual Basic application. And that application runs on the client side, runs on caseworker laptops and PCs, for example. So if we move to the next slide. So the problem here is that software that's designed to solve a single problem is treated as a whole single piece. So conceptually and literally, you have one piece of software that addresses a large problem. And as I talked about this before just now, when we're talking about this one piece of software, it's very, very hard, or it's harder to tease apart the individual parts of functionality. So you have a lot of interrelated functions. And what this means, and one practical example of this might mean that if you have, for example, a single client application, so one Visual Basic application that your caseworkers use on their laptops, on their computers, it is somewhat harder for you to update or upgrade part of the functionality of that application than it would be to, it's harder for you to update part of the functionality of that application because ultimately you end up having to recompile that entire application and then deploy that entire application when really all you might want to do, for example, might be to update the workflow for intake, or you might want to add a new option for attaching documents in the case management section. So moving on to the next slide. In this way, with that type of approach, with that monolithic approach, when essentially you're saying, I have the entirety of all of the problems of child welfare delivery to solve, and I need one piece of software that will solve all of that. I want a one-size-fits-all solution. Then in this way, you end up with a single piece of software that addresses all of child welfare. And what we've seen are the problems with that it makes it significantly harder, or what we've seen definitely in the commercial sector, is that when we treat software like this, it is hard for us to move quickly. It's hard for us to develop and deploy lots of small upgrades over time. So it's harder for us to do continuous improvement of a particular piece of software or a service when we're dealing with this large monolith, because there are so many interdependencies. So moving on to our next topic, modular design compared to monoliths. So on the next slide, in modular design, instead of designing one piece of software that addresses the problem as a whole, broadly speaking, we break up the problem and the software into smaller pieces. So I've got a couple examples for you on the next slide. So the first example would be, instead of trying to design and build a car all at once, and from a conceptual view and from a practical view, having to keep in your head or having to keep in a vendor team's head everything that the car has to do, instead of trying to design the entire car at once and keeping track of all of those interdependencies, we would design each of the components of the car one by one, and then we would have an eye on how all of those components, all of those modules would fit together. So we would spend some time designing the doors, designing the engines, designing the gas tanks, and so on. So we would take this large problem of figuring out how to design a car, and then we would decompose it into, well, what are the different components that we need for this car? How do we make sure that we address each of them in a way that best suits the needs of their users? How can we write that code? How can we develop that code that addresses those problems in a way that we know will be reliable, so that we can then replace those? The second example, and this might be a more accessible one, is that I think we can all imagine that trying to solve a 256-piece puzzle in one attempt might be really difficult. You've got all of these bits and pieces to take care of. You've got all of these bits and pieces, and you're trying to figure out how they fit together. An easier way might be to break it up into 16 smaller puzzles, each of 16 pieces each. So you can work on each kind of individual subset. And I think some people, or at least I've seen this with my 3-year-old, instead of trying to solve the entire problem at a time, he might look at his jigsaw puzzle and he'll say, okay, well, I can fit together all the pieces that make up the picture of the sun. And then he can put those together, and then he can work out how that fits together in relation to the rest of the jigsaw puzzle. So the big thing here, when we're talking about modular design compared to monoliths, is the decomposition, so the breaking up of a very big problem, or a piece of software that might try to do everything, into smaller pieces of software that each do individual jobs. And then our work then is defining the way that each of those modules communicate with each other. And the benefit that that gives us is that we can then replace each of these modules, because what becomes more important is the contract, or the API, or the agreement of what each piece of software, what each module does for each other module. So if we move on to the next slide, 3.3, modular design applied to child welfare. So, a modern automated child welfare information system should meet all the needs of children, families, caseworkers, and managers to ensure the safety and well-being of at-risk children. Modern modular software would meet those needs through a set of separate reusable modules that communicate with each other. So I can take you through 3 example CCWIS modules next. So the first one might be an intake module. And I've described the intake module here using a form of description called a user story. And this is how we describe kind of high-level functionality when we're using iterative or agile development. So an intake module might need to do this. As a caseworker, I need to record incoming information about clients and search existing information so that I can make a determination, like opening a case and assigning it to a caseworker. Our next example is a case management module. So as a caseworker, I need to record information and share information about my client. I need to keep track of tasks and dates so that I can manage care and services throughout the lifetime of a case. And then finally, a resource management module. So as a caseworker, I need to quickly find and order and book appropriate services for my client so that I can ensure my client's safety. And then on the next one, a similar story for some other tasks that a resource management module might do. So for example, as a licensor, I need to investigate license applications and complaints so that I can issue, amend, or revoke licenses. And then finally, a data exchange module. So as a caseworker, I need access to data to be able to easily access court information and submit information to the courts so that I can spend more time with my client instead of doing admin. Now, each of those example CCWIS modules, I would say, are an example of if you did a breakdown or if you did an analysis of all the different types of work that caseworkers need to do, or all the work that's involved in delivering child welfare. I think what you end up coming up with are common areas. So, for example, in the work that I did with California, we started identifying high-level kind of groups of tasks, and those high-level groups of tasks were what informed what became RFPs and RFOs and requirements for modules that we wanted to develop or that we wanted to procure in California. So moving on to the next section, I'll talk a little bit about why and how modular design will be better, and why and how this approach should be better for how you procure and how you develop and also continue to improve your automated systems. So I talked a little bit about this already. Modular design makes it easier for your software to meet your users' needs. So one thing to focus on is that well-designed modules focus on doing one thing, not many things. So a system is then made up of independent modules, and that means that you should be able to choose the right module that meets the needs for specific users and specific tasks without affecting the rest of the system. There's less need for you to have to compromise. In principle, child welfare services that use modular design or that are intended to have modular design at the outset should be able to mix and match commercial off-the-shelf software, open source software, and software as a service as needed so that the best tools can be used for the job. The next point is that modular design makes it easier for your service to be continually improved. So when you have deconstructed, or when you think about all of the set of tasks and all of the services that your automated child welfare system needs to do, and you've started organizing them into larger scale modules, then what you potentially have the potential for is, for example, to say, you know, there are lots of improvements, or there are a number of improvements that we would like to make to intake, or there are improvements that we would like to make to resource management or to data exchange. Because we have separated out the functionality of our software, and because we've separated out the implementation of our software, that makes it a lot easier for us to update just one module without affecting the rest of the system adversely. It also means that in some cases where we improve one module, then all of the other modules in the system are able to take advantage of those improvements as well, because there is a lot more scope for shared services when we think about and when we apply modular design. The last point is that modular design has the potential for you to deliver more reliable software more quickly and for less cost. So on this first point about more reliable software, designing a modular system means that you can test and ensure the functionality and reliability of individual modules as you go. So one of the issues that we've had with traditional waterfall and monolithic software procurement and technology procurement is that we build all of this functionality, And then only at the end do we get the first real chance to test how all of that software works. Only at the end do we start integrating it all, and only at the end do we start being able to test how all of that integration works. If we're dealing with a modular system, that means that we can test and ensure the functionality and reliability of individual modules as we go. And that effectively means that we're able to take the big problem of doing all of our testing at the end of a traditional waterfall and monolithic system, and we can test earlier rather than later so that we can find out sooner about any potential problems or any potential risks. The second point is that we're able to deliver software more quickly. So again, if I can go back to the jigsaw puzzle analogy, it's going to take us a lot longer to finish and complete a 256-piece jigsaw puzzle than it is going to take us to finish, say, the first set of 16 pieces of that jigsaw puzzle. So again, this is a benefit that we're seeing in California, where California had taken their monolithic procurement and they've broken it up into a number of modules. So the principle here is that when we take a big problem and we decompose it, we break it up into smaller problems, then we can solve those smaller problems more quickly. And that means that the entire system, we can deliver functionality for the entire system in a phased way or in a gradual way rather than waiting, and then getting all of the functionality at once in 5 years' time, for example. So there may be off-the-shelf software, or there may be software as a service that you can order, that you can use for modules that already exist. And in other cases, there may be software that you want to develop yourselves. But again, the big principle here is that when you think about it, is that employing a modular design makes it easier for you to prioritize. It will make it easier for you to figure out, well, if we're doing a transition from a legacy system to a new CCWIS system, or if we're starting from scratch and we're delivering a brand new CCWIS system, then it allows you the flexibility to talk to your users and figure out, well, what problem do we need to solve first? If we figure out what problem we need to solve first, then that helps us prioritize which modules we work on first. That helps you put together a plan of prioritization. And what that will mean is that instead of waiting until the entire system is finished, you're able to start delivering software that works for your users better. And the last point, everyone always wishes that they could get technology delivered less expensively. And in modular design, the potential is that you're able to mix and match existing services. So, for example, what we're seeing in the child welfare space is that there are starting to emerge software as a service modules, or software as a service or subscription services, or off-the-shelf commercial software that might be very good at doing a specific job, and that can potentially be cheaper than you developing your own. So moving on to section 5, getting ready for modular design. So I'm going to cover 3 topics in this section. I'm going to cover connecting modules together, building and updating shared infrastructure, and then lastly, maintaining a common data structure. For the first point, connecting modules together. The big point, one big thing about modular design is that you're going to instantly lose the benefits of modular design if your modules communicate directly with each other. And this was a concept that I spent some time on with the management team in California, helping them to understand. If we design a system of different modules that each do their own job and then they communicate directly to each other, then that is going to lead, again, to a more or less monolithic design where everything is connected to everything else. You're going to still end up with the same tangle. So moving on to the next slide. Instead, it's better for you to have an API called data module. So an API is an application programming interface. So this API or data module would be one module that all of your user-facing modules talk to. So for example, any module that needs access to data. What we don't want to do is we don't want every module to be accessing data on its own. Ideally, what we want to do is that each module, the intake module, the resource management module, case management module, for example, they all talk to one piece of software that handles all of those data requests. And that data module, for example, can also do the job of being an abstraction layer for your underlying server or your underlying database. So on the next slide, as a bit of explanation, APIs are ways for pieces of software to make their information and abilities available for other pieces of software to use. So again, in modular software, modules would use APIs to communicate with each other. So what we're doing with modular design is what becomes important is defining what each module does and defining how each module communicates with each other. And that definition, that API interface, that governs, that is kind of our contract between what Module A provides to Module B and what Module B expects from Module A to work, for example. That's what enables us, and that's what delivers us the benefit of being able to switch modules out and improve modules later. Because what we can do is we can, provided the modules fulfill the terms of those contracts, those APIs between modules, they're essentially black boxes, which means that we can go in and we can upgrade the functionality and we can improve the performance of each of those modules, provided that we keep to the contract, provided we keep to the API agreement between each of those modules. And then there is a further part to that where we're able to version and increment and improve the APIs that the modules use to talk to each other. So on the next slide, I've talked about this previously. So all of the modules should communicate with the API or data module. And ideally, they should use industry standards like JSON, REST, and XML, which will make it easier for you to replace or upgrade individual modules later. So there are a lot of industry standards in terms of the type of data exchange and the type of application programming interface that each of these modules can implement to talk to each other. And ideally, what you want to do is you want to make sure that each of those APIs are documented. And what that will mean is that provided you have the API documentation, provided you have the understanding or your vendor has the understanding, this is what Module A provides, this is what Module A needs, then any other vendor or any other developer can work to that specification, can work to that API specification, and either provide improvements to a module or provide a drop-in replacement. So moving on to the second point, building and updating shared infrastructure. So one principle of modular design is called separation of concerns. It means that each module or piece of software should focus on doing just one job. Where possible, whenever you find common functionality across modules, that means that there's potential for that functionality to be its own module that other modules can use. So I can give you two examples here. If we had, for example, our 3 example modules of intake, case management, and resource management, we know that each of those 3 modules need to access our database on our mainframe or on our server. Ideally, what we want to do is we want to make sure that we reduce the amount of duplication across all of our software. We just want to write that piece of code once. So that's where we come up with the concept of having a data access module or our API module. That means that we write the code that accesses the database and makes sure that what's going into the database is the right kind of data that helps ensure data cleanliness. We write that module once so that instead of keeping 3 different ways of updating and retrieving information from our database across our intake, case management, and resource management modules, we only write that once. Another example might be our data exchange module. So we could conceive of a requirement where we know that intake and case management, for example, might have data exchange requirements with the court system. So again, instead of including data exchange in the intake module and the case management module, we will then take that out, put it in its own module so that every other module can also use that data exchange. And then the architecture, in the conceptual architecture that we're talking about, then that may well live alongside or as part of the data access module or the API module. One other example on the next slide. So for example, if you're developing a custom system, all of your user-facing modules might use the same user interface module. And this might not necessarily be a module, but this is sometimes called a pattern library or a style library, or even just a JavaScript library, but the intention here is the same. If we're developing custom software that will provide, say, a web interface to a number of different pieces, different pieces of functionality, ideally what we want to do is we want to use the same user interface library for all of these modules. That way, if we find an improvement, then we can deploy that improvement. We can apply that improvement once to that user interface module, and then it can become available to all of our software. And then moving on to the last point, maintaining a common data structure. So again, the simplest way to maintain and enforce a common data structure is for all of your modules to access your data in the same way. And this is, I think, emphasizing the point that I've already made. So California's new system is doing this by implementing an API and data access module. So on the next slide, there should be, and there will be no way for modules to access data directly. So the API or the data module acts in a way as our gatekeeper. It means that we have the ability, from a conceptual point of view, from an architectural point of view, we define our data structures once in the API and data module, and then that API and data module provides access to clean, sanitized, checked data to each of our user-facing modules. Moving on to section 6. So I'll talk a little bit about how to move from a legacy monolithic child welfare system to a modular CCWIS system, and I'll use California, my work with California State, as an example here. So there are 3 parts to this section. There's the unhelpfully named strangler pattern, which comes from an industry term. I'll talk a little bit about legacy environments, and then finally I'll talk about where you might decide to start, or how you might decide where to start if you're embarking on moving from a monolithic legacy system to a modular CCWIS system. So the first part, the unhelpfully named strangler pattern. So the strangler pattern is an established industry method of completely replacing a legacy system with a new one. And as I mentioned, California is using this method to move from their legacy system to a new CCWIS system. So the reason why this is called the strangler pattern is because it gradually replaces pieces of functionality of the legacy system, that is, strangling it, until all of the functionality of the legacy system has been replaced and improved. And then and only then, when all of that functionality has been replaced, the old system is turned off. So what that means is that caseworkers and users will be using both systems, both the new system and the old system, at the same time. And over time, their usage will switch completely to the new system, as the new system has replaced all of the functionality of the old system. Now, the chief advantage of the strangler pattern is that it means that you're able to move from a legacy system to a new system more quickly than you might otherwise, because your alternative is we just go off and then we have 2 parallel tracks. We have the legacy system, and then we develop the new system. We might develop the new system under a traditional waterfall method. So say after 2 or 3 years, or after all of our development and all of our integration and all of our user acceptance testing is done, then we turn on the new system in one big bang, and then we decommission the old system. So the alternative to the strangler pattern is that big bang. We try to replace everything at once. What we found in the private sector is that the strangler pattern helps us deliver value to customers and users more quickly, and it also turns out to be more reliable because we're able to test that system as we're going along. We don't have to wait, for example, for 2 to 3 years for all of development and integration and testing to be done, and then see how that system works. It means that we're able to see how the new replacement system works in gradual stages until we finally completely replace the legacy system. The second point that I was going to talk about was about legacy environments. So my experience has been that most legacy child welfare systems are monolithic client and server systems. So mostly the child welfare systems that I've seen are using databases like DB2 or AdaBase that are running on solid, reliable mainframes. And what I've typically seen is that for the size of database and for the number of transactions that the database needs to support, typically the hardware is over-provisioned so that there aren't really any performance concerns purely from the point of the database running on the hardware, not talking about network connectivity or anything like that. On the next slide, though, we see that the client situation is more complicated. So caseworkers typically use monolithic Visual Basic applications that were developed in the 1990s, and those Visual Basic applications talk directly to the server and talk directly to the database. In some cases, they may not even talk over modern protocols like TCP/IP. They may talk just directly over protocols like SNA directly to the database, or they may use transaction gateways that are particular to the database environment or to the mainframe environment. And on the next slide, what we normally see, or what I've normally seen, is that these legacy Visual Basic clients, they've become very hard to update, they've become very hard to support. Some of them may have reached end of life in terms of support for their programming environment or their runtime environment. And we also see that they don't support the mobile needs of caseworkers very well. But what we've also seen is that because these Visual Basic clients are monolithic, because they are all of our functionality, everything that a caseworker needs to do rolled into one application, and they don't take this more modern approach of saying, okay, well, here are different modules that deliver different services, and all of these modules work together and are able to communicate with each other through an API layer. We're left with a problem where we have one big ball of code. We have one monolithic ball of code that does everything. And that becomes harder and harder for us to support. So given all of that, where might you decide to start? So the exercise that we went through in California was taking a look at the documentation and the work that the team there had already done in terms of understanding their user needs and understanding what their pain points were. And this can sometimes be a difficult exercise, but it does mean that you need to think about everything that you're doing, and it means ultimately that you need to prioritize, because unfortunately we can't ask for everything at once, and we won't be able to get everything at once. We can get things in order, and we need to decide what we want to spend our time on first. So one way to decide where to start is to take a look at what your system does, what your caseworker needs, or what the particular needs are of your system, and then what might provide a definite and quick win for your users. Some other questions on the next slide might be taking a look at what your server or mainframe environment looks like. How stable is your server, and how stable is your mainframe or database? And if you're running on a state mainframe, if you're running something like DB2 on an IBM mainframe, or if you're running AdaBase, then chances are that your database is probably pretty stable. If instead you're running on a system like IBM Notes or IBM Domino, then you might, I've seen states where they're kind of hitting the limits of those systems, and that database or that environment is significantly less stable. But one thing that you will probably want to do is to find out how easy it would be to take a look at that server environment and find out how easy it would be to provide a modern RESTful web API. So again, this would involve taking a look at your mainframe, your database environment, and saying, if we want to build new services, if we want to build this data module or an API module that will allow us to deploy, to buy, or build new modules that work on top of that, then one of the first things you're going to need to do is provide a way for your legacy database to communicate with these new systems. Next, you'll want to take a look at what your client environment is like. So again, are all of your services provided through one application, like a Visual Basic application? How easy might it be for your caseworkers to move from one application to another? One piece of information that I've always encountered with every single state that I've worked with from California onwards has been a concern that caseworkers won't be able to or will be reluctant to work with two different systems. So, for example, with their legacy system and a new system, and then conceptually it will be difficult to deal with both types of systems having to switch backwards and forwards and backwards between them. And what I can say is that in practice, that doesn't normally seem to be a problem. What really matters is making sure that there is a clear kind of logical delineation. There's a clear separation between I know what I'm using the new system for and I know what I'm using the old system for. On the next slide, for a typical child welfare system, a quick win might be to deliver new and better functionality in a specific area to caseworkers. So, for example, in California, one of the things that we found that would be most useful to caseworkers who perform intake functions would be better search. So even as they are using their legacy system to do the bulk of work of recording information about potential new clients, a better search mechanism for existing information, we found out from them, would make their jobs a lot easier. So following from that, one of your questions might be, well, how does our server communicate with our existing clients? Does it only talk to existing clients? Is there a way for it to talk to, for example, different types of web services? So on the next slide, in that situation, to deliver any new functionality to your caseworkers, you then might need to deliver, or you might need to build or procure an API or data module so that new services can access your existing data. In that way, you would build potentially two modules, or you would procure two modules. One, this API or data module that would act as a foundation upon which you can build other services and other modules. And the second one might be search functionality that is your first step in a new intake module. On the next slide, if you do go down the route of building that API and data module, as we've talked before, that module should handle requests to your existing database. As a first step, it's a good idea to make sure that that API module is read-only, so it only provides read access to your legacy database. We want to make sure that we incur as little risk as possible as you start building functionality, and then long term, that API module should be built or should be procured with the goal of providing a modern and standard interface for all of your other modules to exchange data. And again, so based on California, and lastly, here are the example user-facing modules that we found in California. So intake, case management, licensing. California has actually decided to roll licensing in along with resource management. Eligibility, financial management, reporting, and also data exchange. So that wraps up my prepared remarks and my prepared slides. So I think we're able to open it up for discussion now.
Perfect. Dan, thank you so much. That's a lot of great information. So, operator, could you remind us again how people can line up on the phone to ask questions?
Thank you. Yes, we're ready to begin the question and answer session. If you would like to ask a question, please press star followed by 1 and record your name clearly. Again, that is star followed by 1. And 1 moment, please, for our first question.
All right. I'd also like to remind folks that they can submit questions via the question box, which is in the GoToWebinar control panel. If you don't see that panel, you should see a small orange arrow usually on the right side of your computer, unless you've moved it elsewhere. And if you click on that, that will open up the control panel for questions.
At this time, I'm showing no questions on the phone line. So again, if you'd like to ask a question, just press star followed by 1.
Okay, and we do have some online. So, Dan, I'll go ahead and start with the first one. Is there ever a chance or a risk that as you move from module to module, that when you finish the first or second module, it just won't fit with sort of the final Evolve product, and you just have to go back and redo the first few pieces?
So the question there was, and I assume the question is more along the lines of, as you are procuring and building or delivering a modular system, that there's a risk that the modules just don't work together. And I think that question kind of underscores the importance of the API module or of the data module, because remember, each module has one job, which essentially is to talk to that API module and talk to that data module. They won't talk to each other. Now, in terms of the modules not working together or the modules not fitting with each other, that risk should be minimized if you always think of, well, each module only ever talks to one module, which is the API and data module. So there's less chance of the modules not fitting together side by side, if you will. I think the question may also be around the risk that there might be some missing functionality, for example. And I think there, that risk can be mitigated by making sure that you understand the domain and you understand the area and the type of problem that each module is supposed to address. It may well be, for example, that in your case management module you find that, and I'm just speaking off the top of my head, that you find that your case management module, ideally you would like access to information that might not have been gathered during the intake phase, during the intake stage of a case. In which case, what you might want to do, or what you might need to do, is you go back to the intake module and you say, okay, well, there's additional information that we might want to gather. But in principle, for a situation where you say, okay, well, it feels like there's a mismatch between what's being gathered at the intake stage and what's available at the case management stage, if you are using an architecture, if you are using a design where each module just talks to the API or data module, then it's a question of saying, is the intake module providing all the information that is captured to the data module so that it can be stored in your database? And then it's a question for the case management module, is this pulling all the information that it needs?
Perfect. Thank you. At this time, I also wanted to remind our audience, if you have CCWIS-specific questions, please email those to the Division of State Systems mailbox. It is CCWIS questions, all one word, at acf.hhs.gov. And DSS staff will then address those questions, and then they may be incorporated into ongoing guidance for the larger discussion. Again, that mailbox is CCWIS questions, all one word, at acf.hhs.gov. Do we have questions on the phone?
We do have questions. We have one. The first one's from Mark. Your line is open. Go ahead with your question.
By the modular design, do you mean that by having the first module designed, you still use the legacy database, or you have separate database for that to capture the information?
So the question was, if you have your first module designed, then are you still using a legacy database, or are you using a new database? And I would say that it depends on which module you are implementing first. And it depends on, so it depends on which module you're implementing first, and it depends what kind of features you're implementing first. One of the things that we looked at in detail with California in terms of determining which module to implement first was also the impact on the database. So in California, because we are doing intake first, and because case management won't become fully online for at least, say, 6 to 9 months after intake, what that means is from a process point of view, although someone might use a new intake service to record a new client, that information has to go into the legacy database so that it can be accessed by people who are still using the legacy case management system. So what the data and API module needs to do is it needs to understand and it needs to decide, okay, well, from a data management point of view, what data needs to go into a legacy database, and where can you keep the schema the same. And ideally, if you're using this strangler pattern, then you need to keep the schema the same in the database to preserve compatibility until you're able to switch all of your services over. So the answer is a bit of it depends. But what we're seeing in California as they now that they've moved into implementation with that API module is that a lot of the early data just goes into the legacy database, and that they will figure out at what point it makes sense to start writing data into a new database and then start doing that data migration.
I do see a problem here. If I hung on my new module and I'm adding more data fields, I'm adding more features, so that means I have to, in a way, to expand my legacy database.
Yeah, well, so I know that we're getting into specifics here. So what we did with California is that we set out a number of principles of, we set out some data standard principles that we did in a working group down in California. So what we decided was that any data that can be written into the existing, so for starters, there are no changes to the legacy database schema. If new functionality can only be supported by new fields in the database, then those new fields are written into a new database with a linking record to the legacy database. But the expectation is that any of those new fields then will not be available or cannot be available inside any of their legacy systems. So the design of a particular module there, when they're migrating from legacy, when they're transitioning from legacy to a new system, is that new functionality to a certain degree, or the default principle is that new functionality is only ever available in a new system, and the legacy system only has access to legacy data.
Yeah, I do see there's some problem. That means you are growing your new database per module and to build out a new database structure.
We don't necessarily. I have to say that from the California point of view, we don't necessarily see that as a problem, because even given the size of California's database, compared to what the private sector has to do these days, it is more on the trivial end of database design.
Okay. And another thing is you have do a modular approach. You try to switch out of the legacy system, but you have to remember that legacy systems are not modularized. How do you handle that?
So I think the question there is how do we? I think what you're potentially getting at is that a legacy client application might not be modularized.
That's correct.
So how do we switch off, or how do we prevent access to what would be a new module in the legacy client application? Is that right?
That's correct.
Right. So that becomes part of the work of the MNO contract with the existing vendor, and that is work that we did in California. We did some exploratory work in California to say, in principle, is it possible for us to either turn off or prevent access to certain features in the legacy client application, because we need that in order to help people switch over to the equivalent new module. So you're right that that is an issue that needs investigation when you are using this approach.
Yeah, that means you have to work on a new module. In the meantime, you have to work on the legacy system as well, just to turn it off.
Well, we're attempting to minimize the work on the legacy system. So, for example, one option for the legacy system may well be, and you need to take a look at as to whether this might be acceptable risk to you. But one option may be to do minimal work on the legacy client application, to say, from a user interface point of view, can we remove access to some of these functions, but that we still leave them live, as it were, on the server end.
Okay. Just my comments on the 256 pieces of jigsaw puzzles. You try to divide them up into 16 piles, then you might have a problem because they are all in the mix how do you know that the 16 piles, the pieces, will be able to assemble? That's just my comment. Yeah.
Right. Okay. Yeah. Yeah. I think the analogy there was is that you work on pieces of the puzzle, or you work on parts of the puzzle, rather than trying to do the entire puzzle at the same time. That you find pieces that stick together.
Yes, that's my question. If you mix them up ahead of time, you won't be able to find which pieces belong to which part. That's all. I'm just,
Right.
Thank you.
Right. Sure. Thanks.
So I'm sorry to cut this off. We do have some other people with questions online. And before I go online, operator, do we have other people on the phone?
We do have a question from Andrew Vick. Your line is open. Go ahead with your question.
Hello. I'm a developer with the state of Maine who's currently working on a monolithic system. And I'm having trouble understanding how validation is handled in the modular application, a modular design between the data module and the user interface module. For example, if you have a placement screen that has to validate that the start date is not null, it has to check for overlapping placements, and it has to check with whether the resource is licensed. How is that distributed among the different modules?
So off the top of my head, I would say that you should perform simple data validation. So things like, is this a valid date? That you can perform them at the client level. So at least in the way that I think about it in my head, that you would provide them, you would do them at the user-facing module level, potentially in the browser. If you're talking about specific types of validation, like is this resource licensed and is this available, then that would be a query to either, if that information is in your database, back through the data access module, or back through the data API module to query the status of a resource.
All right.
So I think, and again, I'm just thinking off the top of my head. I think your question depends on, are you querying, or for example, are you trying to validate persistent data that has been stored in a database, in which case you go through the API module? Or are you calling an API, or are you trying to perform a function that would be in the resource management that needs to be, or you're calling a particular kind of resource management specific function, in which case I think you would still go through, or you still would mediate through the data API. So the data API would, for example, present a resource object, and then you would call the API on the data module that would then call the resource management module.
Okay. Does that answer the question?
Yes, thank you.
Okay, perfect. Do we have anyone else on the phone?
We do have another question, and that comes from Svarshan PJ. Your line is up, and go ahead with your question.
This is PJ from Kentucky. We're wondering if through modular design you also recommend a single integrated user interface solution to users who use multiple modules, or are you thinking of separate modules that are not integrated into a single UI?
Ideally, you will use a single UI, but obviously if you are mixing, matching, especially with commercial off-the-shelf or software as a service, then your opportunity to do so will be limited. I'd say that it's the intent that if you are using commercial off-the-shelf, or if you're using software as a service, that you are able to assess as part of your procurement process the suitability and the accessibility of the user interface of those respective services. But I would definitely say that for custom-developed modules and custom-developed user-facing modules, that you always try for a consistent user interface across services.
Okay, that helps. I do have,
yeah.
if we do end up procuring certain modules from vendors, is there a recommendation on how you apply security on that, people who have access to that and stuff like that?
I have to admit, not off the top of my head. It is something that I know is being worked on in California. For example, I don't know if, or for example, I know in California that they are moving from a security model that was completely handled on the server to on the mainframe using a piece of software called RACF. In California, there is an agency move to an agency-wide identity and access management service. So what they would be looking for if you're going to implement an IDAM service is which of your and how do your third-party modules work with your IDAM service, and how might you handle things like single sign-on.
Thank you.
Okay. Do we have other questions on the phone?
At this time, I'm showing no further questions.
Okay. Well, we have quite a few that have come in via the chat box. So, Dan, I have one for you that has 5 different parts, so I'll try to cover them all.
Okay.
Besides California, are there any other states that have adopted a modular approach, and if so, which states?
I know that there are states that are currently investigating a modular approach. So as part of my consultancy with ACF, I have been working with Mississippi, with Arizona, Connecticut, and New Mexico, I think.
Okay. This is like a pop quiz for you. I'm not sure you know this necessarily off the top of your head, but which modules did they work on? Or are they considering working on?
Which modules are they considering?
Yeah, or have they worked on?
I think all states are pretty much behind California in terms of procurement process.
Okay.
So I think outside of California, every state is still in the RFP, in the preparation for an RFP or RFO process, or are still going through, I think, the ADP with ACF.
Okay, and that's actually a really nice lead-in because you'll be talking about agile procurement and development for us in September, correct?
That's right.
Okay, so I'll talk about that a little bit at the end, but we'll be giving more information on that in September.
And Maryland, sorry, I was just reminded by one of my colleagues at ADNF that Maryland is also investigating and is also attempting to adopt a modular approach.
Oh, fantastic. My home state, you can't leave them out.
Yeah.
What specific technology has been used with API interfaces?
And I think I'm able to talk about this because California's procurement for the API has been awarded. So specifically with California, they are running DB2. Their legacy environment is DB2 on an IBM mainframe. They are including, I think, or they are upgrading to the TCP/IP and SQL connector in the IBM 6 transaction gateway. They will be writing the API services in Java. And then I think they're also running Nginx to provide the API and RESTful web services. So broadly speaking, the software development environment for California's API module is Java running on AWS.
Okay. And last part of this particular question, can customized COT systems be used as modular components?
And the answer to that is always, it depends on how much they're customized and what the COTS components are. I would, yes, I don't see any reason why not. And again, it will always depend on the type of COTS component. Again, from my point of view, the degree of success that a COTS component might have will be dependent upon its adherence to open standards and open data formats. If a component does not or is not able to adhere to open standards and open data formats, then you are not going to reap the benefits of modularity, because modularity also does imply that whether you want to or not, or whether you want to change or not, it's likely that technology will improve, and there may well be a better option for that particular module that may not come from the best vendor, from the best contemporary vendor. So one of the reasons why I think ACF are excited about modularity is that it helps states keep options open, and it helps reduce vendor lock-in. It means that if we use modular design, if we make sure that those modules adhere to open standards and open data formats, then we stand a greater chance of being able to switch to better solutions or better services, better products when they become available. The second part will be, it will always depend on the degree of customization that you need. So if a piece of COTS software is intended to work alongside other software, then that may be a good indicator that you may have to do minimal customization, versus if it is, say, for example, a large legacy enterprise product where a vendor is able to say, well, in theory, this supports a degree of customization or configuration that will allow it to work with other services, then I would be more nervous about that. And I think I think there's a recent truism that was coined by one of my colleagues who said that there's no such thing as COTS, or there's no such thing as customizable COTS. There's only incredibly unrecognizably modified commercial off-the-shelf software. So again, that is a big consideration when looking at COTS, is what is a realistic amount of customization that is practicable, and was the software designed to be customized in that way and used alongside other modules in that way.
Okay, perfect. Do we have other questions on the phone, or should I keep moving through with our online questions?
Again, just press star 1 to ask a question on the phone lines, and we do have one question. That's from Mark. Your line is open.
I'm sorry. Hello.
Hello.
Just want to clarify one thing. You kind of designing your new CCWIS data structure along with the new module implemented. Is that a correct statement? I have a legacy database structure schema set up, and so when you develop a new module, then you start to design the backend database structure, say in the Oracle environment, based on the new module. And you kind of pile them up piece by piece together, and that'll be your entire new CCWIS system's data schema.
I would say it depends. If you're working in an iterative basis, then yes, you are going to extend that schema as and when your requirements show that you need to extend it. Okay. But I think there's a very, very big area in which you are kind of, obviously I don't think that you should be changing your data schema every few days as you're developing and designing a new system. But at the same time, with an iterative and agile development methodology, then you're going to recognize that at some point you will probably come up with information that means that it might make sense for you to change your data schema, and it might make sense for you to extend it. I think, again, in comparison to the technology and the capabilities that were available about 15 to 20 years ago, when we were first implementing these legacy systems, there is significantly less overhead to having multiple databases and to having multiple data stores, especially compared to the way that the private sector has moved ahead with the size and complexity of their databases. So even with big systems like California, I think that the type of I think that the load, the transaction environment, and the amount of data that is required for a large state system still pales in comparison to what the private sector now has to deal with.
Okay, thank you.
Sure.
Okay, Do we have anyone else on the line?
This time I'm showing no further questions.
Okay. So going back to questions that people have submitted via chat, in using modules, particularly the idea of a purchase module, how do you achieve a common, consistent visual interface across modules for the user?
So I think we may have covered some of this question already. I think someone came in with a question about how you or can you implement a consistent user interface across different modules. And again, the answer there is going to be you will be somewhat constrained if you are using a mixture of off-the-shelf or existing software as a service. Where you are developing your own software or where you're commissioning the development of your own custom software, then I absolutely recommend you using standards like the US Web Design standard, which is available at playbook.cio.gov, as well as following the US Digital Service Playbook. And as it extends to the customizability of software as a service, so for example, if you're using something like Salesforce, or if you're using other types of off-the-shelf services, then do take a look at things like how customizable the user interface there is, because while you may not be able to do things like necessarily change form layout, you will want to make sure to see if even simple things like the copy that is used in the interface and the words that are used in the interface are able to reflect the interface standards that you build out across the rest of your complete set of software.
Okay, great, thank you. And I think you also touched on this a little bit with the earlier question about security, but I'll go ahead and put it out there in case there's a little more to add to it. As modules communicate with each other, what design considerations need to be taken into account in order to ensure the protection of sensitive data?
I'm sorry, could you repeat that question again?
Sure. As modules communicate with each other, what design considerations need to be taken into account in order to ensure the protection of sensitive data?
Okay. So the question there, how do you protect sensitive data, and what kind of design considerations are there for sensitive data? And again, I think what you have here is with a data and API module, you have the ability for that module to act as the gatekeeper for PII or for sensitive information. So I think what you're able to do is you're able to make sure that at that data and API module, only modules that are, for example, allowed to access that data or should be able to have access to that data are able to access that, and that only authenticated users who also have authorization to access that data are able to access it. So again, the principle here is that no software should be directly accessing your database that has your sensitive data in it. All of the access is mediated through this API or data module. And that from a design point of view, that data and API module is your kind of one point where you decide this is how we authenticate and this is how we authorize access to that type of PII information. What that means is that you have, you're essentially trying to centralize, and you're trying to say, okay, well, if any module wants to access PII, then there is one place where you go to access it. So we make sure that that we only need to write that code once, and that makes it easier for us to maintain that code, and that makes it easier for us to make any changes to that code.
Okay, perfect. Just a reminder, too, to our audience, when you're thinking about COTS products, you should be in touch with your federal analyst about the use of COTS products for specific solutions or to get specific answers to your questions. And also remember, for specific questions about CCWIS, please talk to your federal analyst or send your CCWIS questions to ccwisquestions@acf.hhs.gov. I'll remind you all again at the end, but I just wanted to put that out there right now. Another question we have is, how important is it to have the same vendor or developer build individual modules?
So the question there is, what kind of benefit is there to have the same vendor build or develop each individual module? And I would flip the question around in some ways and say it depends on how suitable the vendor and whether the vendor has expertise in each of those modules. One thing that we have seen, and I've kind of alluded to this in our conversation so far today, is that a big role for example, lies in this data and API module, because it's that module that effectively manages all of the communication amongst different modules and makes sure that each module or each piece of your software gets the data that it needs. And that's where a lot of design considerations need to go in. In terms of whether it makes sense for a vendor to work on multiple modules, there can be some instances where you already have a vendor who's familiar or there are adjacent domains. So, for example, intake and case management. It may be appropriate or there may well be benefits for a vendor to work across both of those. There can also be a case where it makes sense for the vendor who provides or develops the data access module or the API module to also work on one of the first user-facing modules, because that will essentially be your first test of, okay, well, how is our data being provided, how are communications being mediated between modules, so that they can work together that way.
Okay, great, thank you.
But again, I would say one of the advantages, the big advantage of modular design is that you're able to pick the right module, you're able to pick the right software that does the right job and does it well for each particular group of tasks. So while in theory there may be some contractual benefits or vendor management benefits to having the same vendor work on multiple modules, from my point of view, the intent is how do we make sure that we get the best possible software for the people who need to use it, and that we get that software from the most qualified vendor.
Okay. We just have a couple minutes left. Do we have any other questions on the telephone?
At this time, I'm showing no questions.
Okay. I will go ahead and ask one more, and then we do have a few more online, and so what I would ask Dan is, can I send them to you, and we can maybe send out responses via email to the group that's been participating? Okay.
Absolutely.
Okay. So the last question we have time for is, if the legacy database design is suboptimal and needs a new design, how would you implement then a strangler pattern?
Ooh.
Yeah, I thought I'd close with an easy one.
So the question was, if the legacy database design is suboptimal, how would you implement a new one? Mm-hmm. And I think I can honestly say that at that point, you talk to a database architect, and you figure out what your needs are for a new database system. And I'd also say that it's difficult for me to answer that question without understanding in what ways your legacy database design is suboptimal. Okay. So, for example, is it too slow to access? Are you having problems with transaction processing? Do you have, for example, a weird design where you are storing, like in California, you're storing, you're effectively using your DB2 database as a document management database, and you're storing all your documents in there as blobs, and you need to get them out. So I'd say that is a very, very wide question. I would be happy to, pending the okay from my managers at ACF, I'd be happy to have a separate discussion if I have the time for that to be able to get into specifics.
Okay. So again, I think that would be a good time for our asker to reach out to the federal analyst and see if there's more that can be done around that question. I'll also take this opportunity to remind folks again about the CCWIS mailbox, CCWIS questions at acf.hhs.gov, to direct any CCWIS-specific questions, and a reminder to reach out to your federal analysts regarding COTS products and solutions. Dan, I want to thank you so much. You've had to really work pretty much nonstop for the last 90 minutes to share some really wonderful information with our group. So I really do appreciate it, and I think this was just an incredibly valuable session. Also, I'd like to thank our audience who's been really engaged and asked some really fantastic questions. But Dan, thank you so much for your time this afternoon.
Great, thanks very much.
All right, and for everybody, we will have Dan back with us to talk about Agile Procurement and Development on September the 7th from 1:30 to 3 o'clock. That webinar invitation went out yesterday, so please block your calendars, September 7th, 1:30 to 3, and plan to join us for a follow-up discussion on procurement and development. With that, I'll let everybody go and wish you all a happy Tuesday afternoon.